Hi, I'm Ria and this is our science project.
Hi, I'm Madison.
Hi, I'm Katharina.
Hi, I'm Ayushi.
Hi, I'm Erin.
And I'm Ashlyn.
As you guys know, most of the project revolves around the particle model of matter.
What's the particle model of matter?
It's the basic fundamentals to chemistry.
It states that everything is made up of particles.
It also says that particles are always moving, and if you add heat, they start moving faster. And if you take away heat, they move slower. Gases move the fastest because they have the most energy, and solids have the least energy, which means they have particles that move the slowest. Liquids are in between.
They have attractive forces and they also have spaces between them.
And the last thing it says is that all pure substances are made of the same particles. J.J. Thomson came up with most of the particle theory with a bunch of other scientists.
Okay, I get it now.
Let's go back to my house now.
Wait, wouldn't the particles in the pavement be moving according to what Ayushi said? But that wouldn't make any sense, because the pavement is so hard.
Actually, the particles would always be moving, but they are moving a very tiny amount. That's why they have a definite volume and a definite shape.
That's right. Come on, let's keep walking.
I'm guessing that air has particles too, but they're not moving.
Why? Wouldn't the particles that make up air be moving too? I'm just wondering.
That's right. But they are so far apart from each other and moving fast that you can't see them. That's why the air is invisible.
That's why air and other gases have no definite shape or volume.
But is there anything that fits in between solids and gases?
Yup, it's liquids.
The particles are somewhat packed together. They are closer together than gases and farther apart than liquids.
They have a definite volume but no definite shape. You can put them into any kind of container.
And together, solids, liquids, and gases form the three states of matter.
Guys, what do you call something when you mix two substances together?
Well, it depends. They're called mixtures when you mix two pure substances together. You can easily remember it because the word mixture has the word mix in it.
But mixtures can be further classified into two other kinds of mixtures. They're called heterogeneous mixtures or homogeneous mixtures.
Mixtures contain two or more pure substances. Homogeneous mixtures look like they are one substance, but actually they are not. They can be separated once mixed by evaporating a solvent and leaving the solute. Another name would be solutions. The particles from the two substances can easily form a bond which helps them to mix. Things that you could find around your house would be homogeneous mixtures like salt, water, and bleach.
While heterogeneous mixtures can be separated in so many different ways. They have two or more parts that we can see. They are called mechanical mixtures. The particle of one substance cannot form a strong bond with the other substance particles, causing a heterogeneous mixture. Examples would be salad dressings and various sauce around your house. But there are some forms of substances that are harder to categorize. They are called suspensions. It is a heterogeneous mixture that looks like a homogeneous mixture, but has particles that eventually settle to the bottom. A heterogeneous mixture that does have particles that don't settle is called a colloid.
And all matter is classified into two things, pure substances or mixtures. We already know what mixtures are, but what are pure substances? I don't understand.
I know all about pure substances. Since mixtures contain two or more different particle types, pure substances contain only one kind of particle. They can exist in all of the states of matter. They can be farther separated into elements and compounds. Elements are the purest substances on Earth. Compounds are made of two or more elements. When the elements mix, they create very strong bonds, and they also start to lose their characteristics. Once compounds are formed, they cannot be separated by any physical means.
Exactly. Matter can be classified as a mixture or a pure substance.
Oh, so this coffee would be a mixture. but it would be a homogeneous mixture because it looks like it's made of one thing. And this water would be a pure substance.
Let's go back inside. It's too sunny out. I don't understand the homogeneous thing. How do you make two things blend so well together that you can't see the different traits they have?
Well, you could try dissolving. It's when you mix two things together that you can't see the different parts that make it. How does this happen? The particles are attracted to each other, so this causes them to become a solution.
Okay, I understand now.
Speaking of science, some of you guys want to see my science room? You can go without me.
Wow, that room is nice. Hey, don't we have different kinds of solutions depending on the solute and solvent?
Wait, what is solubility? And solute and solvent?
That's easy. Solute is a substance that's getting dissolved, and the solvent is the exact opposite. It's the substance that does the dissolving. Say I was making coffee. The coffee would be the solute, and the hot water would be the solvent. And solubility is basically the amount of solute that can be dissolved in a given amount of solvent to form a saturated solution at any given temperature.
And you can get saturated, unsaturated, and supersaturated solutions, right?
So I'm guessing that unsaturated means when you add more solute and it will still be able to dissolve into the solvent. And saturated means that no more solute can dissolve now.
Right, and supersaturated means there is more solute that can be dissolved. Going back to what we were talking about, is there any one solvent that can dissolve everything in the world?
Obviously not, but there is one solvent that can dissolve a lot of things. It's called the universal solvent, and that's water. But does dissolving have anything to do with the particle model of matter?
Yeah, it does. We know that dissolving happens because particles are attracted to each other. The solvent always has a bigger pull on the solute. We also know that particles are always moving and have attractive forces. The solute they eventually mix with the solvent.
Oh, okay.
Do you like it? The room.
Yeah, the room was nice. Earlier today I was researching dissolving, and I came across something I couldn't understand. It was something like the rate of dissolving.
It's actually self-explanatory. It's how fast the solute is able to dissolve into the solvent, and you can't change the rate.
Actually, you can change the rate of dissolving. You can add heat to it and more energy, and simply add more surface area to the solute. And Rhea left, and Ashton's still here. So, anyone up for a bike ride?
No thanks, but I'll ask Ashlyn.
Thanks for inviting me to come biking with you guys. Can we take a break here? Oh yeah, I heard you guys talking about dissolving.
Yeah, we were, but a question just came up. What's viscosity? I saw it on this website for science, but I didn't get it.
Viscosity is basically how thick or thin a substance is. A liquid that is thicker would be considered more viscous, and a thinner liquid would be considered less viscous.
An example would be honey and water. Honey is thicker, so that means it has more viscosity, and water has less viscosity.
And viscosity is connected to flow rate. Flow rate is how much time it takes a fluid to move from one place to another. If a liquid has more viscosity, it would have a longer flow rate. A liquid that has less viscosity would take less time.
Viscosity doesn't seem so important. I mean, where would viscosity even matter?
It matters a lot. Different products depend on how much viscosity the fluid has.
For example, nail polish needs to have the perfect thickness. If it's too thin, it will spread and ruin your whole hand. But if it's too thick, it won't spread and apply.
Another example is motor oil. The oil needs to be thick enough to cover all the parts of the engine and actually lubricate them so that the parts don't get damaged. But if it is too thick, the oil won't spread to all the areas it needs to go. Suntan lotion also needs to be thick enough, but also thin enough so it doesn't drip off before you can rub it in.
Both of these substances depend on viscosity, and so do other fluids. We should get back home. It's almost dark, and we have school tomorrow.
Good morning, guys. It's really nice outside.
Yeah, it sure is. How did our experiment go, Ayushi?
You guys did an experiment? What was it about?
We took liquids of different viscosity and either made them hotter or colder to see what happened. Yeah, so what did happen?
Well, the same thing happened to all the liquids, even if they had a different viscosity. If you added heat to the liquids, it became even less viscous.
If you take away heat, the particles start to slow down and the substance begins to harden.
That makes sense. It's just like from the particle model of matter. If you add heat, particles move faster, and that means that whatever they are in becomes less viscous.
If you add or take away enough heat, you can face changes between the three states of matter.
Viscosity and density are connected, right, guys?
Wait, what does density mean?
Density is the amount of mass in a given unit of any substance. If a substance is more dense, it has more particles in crowded together than a different substance.
Okay, I get it now. But does it have anything to do with the three states of matter?
Yeah, it does. Solids are the densest state of matter, and that's because the particles are the closest together. In liquids, the particles aren't as far apart than in gases, but they are closer together than solids. That makes liquids the second densest.
And gases would be the least densest because the particles are spaced farther apart from each other. But there is an exception to this law of physics.
That's right. The exception is with water. If you put ice on liquid water, the ice will float. But shouldn't a more dense object sink? In case it's the opposite, ice floats on water.
If density and viscosity are related, that means that density and the particle of matter can be related too, right? But how?
One of the points of the particle model of matter was that particles are always in motion, and that if you add heat, they move faster, and if you take away the heat, they move slower. This part of the particle model of matter is related to density.
In case you add more heat to a dense substance, it causes the particles to speed up and move apart. Since there is more space between the particles, it is less dense. This is true for all the states of matter. If you add heat, it will make a substance less dense. If you take heat away, it will cause the substance to become denser.
Okay, I get it, but how would you measure how dense something is? Is there even a way?
To measure density, you have to take two things into account: volume and mass. They might seem like the same thing, but they are different things.
Isn't mass the amount of matter in a substance and volume the amount of space the matter takes up? Like you could have the same mass of water and air, but the air would take up more volume?
Right. The way to measure density is by dividing mass by volume. Density stays the same if the pressure and temperature remain the same. If you change the air pressure, you are changing the volume of a substance. And so therefore you are changing the density of a substance. It only changes a little, but it's still affected.
Okay, I get it now. Hey, school's about to end. How will we get to the bus stop now?
Sounds good.
Hey guys, you guys planning anything for the weekend? How about we go to the beach?
I can't.
Me neither.
Okay, so how about us four go to the beach?
Sounds good.
It's really nice outside. Hey guys, how do you think this boat is floating?
That's easy. It's floating because of buoyancy. Buoyancy is the tendency of objects to either sink or float in a fluid. It's called the anti-gravity law because gravity pulls down while buoyancy pushes up. Archimedes came up with this law a long time ago.
Okay, I get it now, but where would we use buoyancy?
We use buoyancy in floating nutrients down our bloodstream, and planes and boats rely on buoyancy to transport goods and other things. Pollen depends on buoyancy to get from plant to plant. Fishes use their air bladder to go up and down in the water. Submarines use buoyancy to go up and down, too much like fishes' air bladder.
Wow, I guess there are a lot of things that we use that depend on buoyancy.
Hey guys, what's average density?
Average density is the mass of an object and everything on it divided by the volume. If the average density is less than the density of the fluid it's in, the object will float.
Right, but if the average density is more than the density of the water, the object will sink. But where does average density really matter?
In ships, they have tanks that fill with water to make sure the boat is in just the right position in the water. Not too high, but not too low.
The tanks fill with water in denser water and take out water in less dense water.
Okay, I get it now, but that means buoyancy and density are related. But how?
If an object will be buoyant or not depends on how dense the substance is that it is floating on. If the substance is more dense, it will be able to hold weight. But if a less dense object had to hold the same object, it would probably sink.
Oh, hey, look, there are Ashlyn and Maddie. They came after all. I'll go see them. Looks like they got a flat tire.
Hey, Katharina. We decided to come anyways, but we got a flat tire. Hey, I wonder how they got the gas compressed.
Well, the gas is put into a sealed-off container that has really strong walls so the gas can get compressed. External forces are applied, and this pushes the particles of the gas closer together. Gas can be compressed because there is a lot of space between them. Liquids and solids cannot be compressed because the particles in them are the closest they can become. The particles cannot get any closer.
What are the benefits of gas compression? Can we use it anywhere besides tires?
Car tires would be an example. The compressed gas makes the tires hard, which means it keeps the car up. Airbags in cars are used to protect the passengers when there is an accident. This happens because they exert a force when they are compressed.
Hey, but if you compress gases, wouldn't that mess up the balance of the forces?
Well, if there is lower pressure in the inside than the outside gas, the container will collapse. If there is lower pressure outside than inside, the container will expand. Well, the tire is fixed now.
We should get back home. I'll call the others.
Well, we're back now. Hey, do you guys have any idea what hydraulics are? I've got no clue.
They are machines that are operated by using the pressure of a liquid to move it. A hydraulic system is when force is applied at one end and is transmitted to the other end using a fluid of some sort. Hydraulics would be used in brakes, in cars, and in other various places. It was invented by William George Armstrong.
And pneumatics is almost the same thing as hydraulics, except they use the pressure in gases. It's based on the one law that gas can be compressed. When gas is decompressed, the particles move apart really fast, and this causes a steady flow to occur, and this you can use to move an object. This law was founded by Robert William Thomson.
Have you guys noticed that the discussions of the last couple of days have been circled around one thing? Chemistry.
Yeah, but why is chemistry so important?
Chemistry is actually really important. We use it in our everyday lives. We use it for cooking, cleaning, environmental issues, medicine, and a bunch of other places. It's important because the existence of life is based on chemical reactions. You use it without even thinking that you are. Chemical reactions even happen when you're just sitting, eating, or reading.
Chemistry explains what happens to food when you cook it or when it rots, or how you can preserve it, how it interacts with your body, and how ingredients come together to make food. Chemistry explains which nutrients, supplements, and drugs are good for you and which ones are bad for you. They also help make medicines.
They're the heart of environmental issues. What makes a nutrient and a pollutant a pollutant? How can you clean up the environment in a safe way? These are all the ways chemistry is connected to the environment.
You also use chemistry when you clean things. We usually use sprays, and they are made of chemicals. You decide what cleaner is best for your dishes, laundry, your home, and yourself by using chemistry. Chemistry is in bleaches, disinfectants, and just plain soap and water.
Well, that was almost the end of our science project. Now we have some videos for you.